Welcome. We want to solve more complicated equations than just the polynomial ones. Other equations often involve ugly terms such as fractions, roots, and logarithms. In this video, you will learn how to deal with equations involving fractions and see the potential pitfalls. As an application of an equation containing rational functions, consider the ferry between two cities in the Netherlands, Dordrecht and Rotterdam. The ferry speed with respect to the water is v. The water flows with a speed of 8 km per hour. On the way downstream, the speed of the ferry with respect to the banks is increased with the speed of the water and becomes v plus 8 km per hour. On the way back, the speed is decreased by the same speed, thus it is v minus 8 km per hour. The distance between these two cities is 30 km. How high should v be such that the return trip takes 2 hours? You might think 30 km per hour, as we need to travel 60 km in 2 hours, but let us take a closer look. We can rewrite this question as an equation as follows. The time taken for the trip to Rotterdam equals 30 over v plus 8, as the speed in this direction was increased by the flow of the water, whereas the time for the return trip is 30 over v minus 8, as the speed is decreased on the way back. The total time is just 30 over v plus 8 plus 30 over v minus 8. And this should equal 2 hours, so we obtain the given equation. The most basic rule when solving equations is try to make things simpler. Thus the first thing we do is to simplify the equation. The ugly part of this equation is that there are fractions. To get rid of the fractions, we multiply by both denominators. That is, we multiply the entire equation by v minus 8 and v plus 8. This gives 2 times v minus 8 times v plus 8 equals 30 v plus 8 plus 30 v minus 8. I have not expanded yet, because factored expressions can be easier to work with. Only expand if you have a good reason. Notice that you obtain a quadratic equation upon expanding, so we can solve this equation using the quadratic formula, or by completing the square. No simple solution without expanding seems evident, so let's expand anyway. We obtain 2 times v squared minus 64 equals 60v. Dividing both sides by 2 and then simplifying gives v squared minus 30v minus 64 equals 0. Do you see a factorization of this polynomial? If not, you can always complete the square or use the quadratic formula. However, observing this equation equals v minus 32 times v plus 2 equals 0 shows the answers are v equals minus 2 and v equals 32. You should always check your solutions by plugging them back into the original equation. If we plug these results into the original equation, we obtain for v equals minus 2 that the equation is valid, and for v equals 32 as well. In summary, we have found our solutions by first simplifying the equation, then solving the simplified equation, and finally checking the results in the original equation. In our application, the boat must clearly have a positive speed, so the first solution is nonsense. And we see that the boat has to cruise slightly faster than 30 km per hour to compensate for the flow of the water. In the real world, the flow of the river is a little less strong and the ferry just turns its engine faster or slower to make both trips last exactly 1 hour. Recall, rational functions are quotients of two polynomials. If you have an equation involving rational functions and multiply by the denominators, you will always end up with a polynomial equation. You can solve these with the techniques of the video on polynomial equations. Thus, in principle, you can always solve these. Don't forget to end with checking your results in the original equation. In short, the method consists of simplify, solve, and check. I'll now show you why it is so important to always check your solutions. Consider the equation 2x over x minus 1 equals x plus 3 over x squared minus 1. We multiply by the denominators x minus 1 and x squared minus 1 to obtain 2x times x squared minus 1 equals x plus 3 times x minus 1. This gives the cubic equation 2x cubed minus 2x equals x squared plus 2x minus 3, which becomes 2x cubed minus x squared minus 4x plus 3 equals 0. Now we have simplified the problem to a polynomial equation. I already factored this polynomial for you. You can check the results yourselves and obtained x minus 1 squared times 2x plus 3 equals 0. Thus we find the solutions x equals minus 3 over 2 and x equals 1. Remember, we always need to check our solutions. We first check x equals minus 3 over 2, and both the left and the right hand side become 6 over 5, so this is indeed a valid solution. However, a problem occurs if we plug x equals 1 into the equation, because the left hand side becomes 2 over 0, the right hand side 4 over 0. Indeed, x equals 1 is outside the domain of both the left and the right hand side, and can therefore not be a solution to this equation. The problem occurred because we multiplied by x minus 1, which becomes 0 for x equals 1. That an equation is valid after you multiply both sides by 0 is not surprising. To summarize, the basic idea of solving complicated equations is always to simplify, solve, and check.